Archimedes, a Syracuse, a Greek mathematician, is credited with the discovery of angles. He is also credited with designing some innovative machines including siege engines and the screw pump. Hey human, don't ever think that you're the only one who is cute, 'cause we're cuter. And don't ever tell me that only you have relationships, 'cause we have too. And obviously we are always right.
Hi students, it's me again, Teacher Che. In our last video, we talked about angles and angle relationships. And today, we're going to explore more about angle relationships. So smile, relax, and fasten your math belt, and let's go!
The figure shows two parallel lines, line AB and line CD. And here's another line XY, that crosses the two parallel lines at point Q and point P. This line is called a transversal. When parallel lines are cut by transversal, there exist some very unique characteristics of angle relationships, which we're going to explore further in this lesson. Are you? So we have here two parallel lines that's being cut by this transversal. This is a transversal. Note that a transversal can look a number of different ways. They can even be perpendicular. The point is that the angle relationships will always be the same no matter how a transversal looks. But for this example, we will look at the transversal that is not perpendicular to the parallel lines. When a transversal crosses parallel lines, it creates a bunch of angles, and we will explore the relationship between these angles. Now, if we observe these two sets of angles, we can notice that they really look similar. If we will overlap these two parallel lines, we should notice that the angle measured from either lines are going to be identical. This is the most important property of parallel lines cut by a transversal. Now, observe the figure. Okay, these two angles are called corresponding angles. And what does this figure shows? It shows that corresponding angles are congruent. We have here two parallel lines that is being cut by a transversal, and one of the angles known, this angle here, measures 145 degrees. Is it possible that we can determine the measure of the rest of the angles here formed by these two lines, two parallel lines, and a transversal? Yes, of course. We can apply what we have learned about angle pairs and the new one, the corresponding angles, in which it is formed when two parallel lines is cut by a transversal, just like this one. So let's start. So we have here this one, this angle here correspond to this one, am I right? So if this angle here is 145 degrees, this angle measures 145 degrees, since they are congruent, meaning they have equal measures. Now, this part here, can we determine the angle, the measure of the angle here? Of course, yes. They are linear pair, am I right? Do you still remember the linear pair? Linear pair are supplementary, so 180 degrees minus 145 degrees. The difference is 35 degrees. So this angle here measures 35 degrees. Now, this angle here measures 145 degrees. Why? Because they are vertical angles, and you know already that vertical angles are always congruent, meaning they have equal measures. So obviously the measure of this angle here is 35 degrees. They are vertical angles, and they are also linear pair. When you add 35 plus 145, the answer is 180 degrees. So obviously here they are also linear pair. So this is 35 degrees. This one also is 145 degrees because they are vertical angles, and here the angle measured here is 35 degrees. They are vertical and they are linear pair. If you observe, the measure of the angles here with the two lines is being cut by a transversal. We only have two sets of angle measures, the 145 degrees and the 35 degrees. So, can you see a pattern here? Of course, there's a pattern. And to help us remember the pattern, we can label this angle here, the 145 degrees, as O, and the 35 degrees as K. We can use the pattern or the method OK or OK method to help us remember the pattern in which all O's are equal and all K's are also equal. Maybe OK, KO, OK, KO. And when you have O plus K, it is the sum is 180 degrees. So O plus K is 180 degrees. The exterior and interior angles. In this figure, the exterior angles are angles 1, 2, 7, and 8. If you notice in this figure, these four angles are outside these two parallel lines, whereas the interior angles, from the word interior, inside, they are angles 3, 4, 5, and 6, which are inside these two parallel lines. We also have these alternate exterior angles. They are pair, angle 1 and angle 8, angle 2 and angle 7. This one here, angle 1 and angle 8, 2 and 7. If you observe, 1 and 8 are not on the same side of this transversal. They are on opposite sides. Same with 2 and 7. We also have alternate interior angles. So they are angles 3 and 6. They are not on the same side of this transversal, but they are in the interior side. And 4 and 5. If we recall the OK method and compare their measurement, then we could say, if you observe here in the figure, angle 1 and angle 8, they are both O. So, meaning, you could say O is equals to O. So, angle 1 is congruent to angle 8. Same with angle 2 and angle 7, they are both K's. So, K is equal to K. So, angle 2 is congruent to angle 7. If you observe also in the interior angles, you can see here that angle 3 here and angle 6 are both K. So, they are also congruent, and 4 and 5 which are both O's. So, you could say that when two parallel lines are cut by a transversal, alternate exterior angles and alternate interior angles are congruent. Then, we also have these same side exterior angles. Same side, we are referring to this transversal. So, we're going to look at this transversal. The exterior angles, which are 1 and 7, they are on the same side. And also 2 and 8, they are on the same side of the transversal. We also have this same side interior angles. They are interior angles which are on the same side of the transversal, and they are angles 3 and 5. They are on the same side, the left side. And at the right side of the transversal, we have angles 4 and angle 6. Again, we will recall the ROK method and observe or compare their measures, the pair. So we have angle 1 and angle 7. 1 is labeled as O, angle 7 is labeled as K. To recall, when you have O plus K, the sum is 180. So we could say that when we add the measure of angle 1 and angle 7, the sum is 180 degrees. So this part here, 1 and 7, O plus K. Same with angle 2 and angle 8, same side of the exterior angles. 3 and 5, 4 and 6, same side interior angles. So in short, we can say that the same side interior angles and the same side exterior angles are supplementary when two parallel lines are cut by a transversal. So now we will recall and practice what we have learned by answering the following exercises. Shall we start? So we have here what angle pair is shown in the figure below. What's your guess? The answer is they are corresponding angles. You got it right? Next, what angle pair is shown in the figure below? What do you think? The answer is they are alternate interior angles. Next, what angle pair is shown in the figure? Look at the figure. What do you think? The answer is alternate exterior angles. Next, what is the measure of angle 2 and angle 5 given in the figure? That measure of angle 1 here is 48 degrees and this is angle 2 and this is angle 5. We will notice or observe that the relationship of angle 1 and 2, they are, what do you think? And notice also the relationship of the given angle 1 and angle 5. So what is your answer? The answer is measure of angle 2 is 132 degrees. How do you get it? The reason? The two angles are linear pairs, so meaning they are supplementary. So when you subtract 48 degrees from 180 degrees, the difference is 132 degrees. How about measure of angle 5? The measure of angle 5 is 48 degrees. They are the same. Why? Because they are corresponding angles. You got it right? Okay, let's try this one. We're going to find the value of y and z given the figure below. So this is the z, represent this angle here, and the y here. Given the measure of angle here, which is 105 degrees. So how do we get the answer? How to find the value of z here and y? So take note or notice their relationship. What do you think is the relationship of the 105 degrees here and the Y and the Z? Remember the OK method? It might help you. So, what do you think is the answer? Angle Y, or the value of Y, is 105 degrees. Why? What's the reason? Angles with measure 105 degrees and the Y are alternate exterior angles. To recall, alternate exterior angles are congruent when two parallel lines are cut by a transversal. And the value of Z is 75 degrees. How do we get 75 degrees? Z and Y are linear pair. So, if we have here 105 degrees, is the value of the Y. So 180 degrees minus 105 degrees is 75 degrees, since they are supplementary because they are linear pair. Find the value of n and determine the measure of angles 1 and 2. So given here in the figure, we have here the measure of angle 1 represented by the expression n plus 3, and the measure of angle 2 is represented by or equal to the expression 2n minus 45. So what will be our first step? We will examine or determine the relationship of the given angles here represented by expressions. So how are they related to each other? What are they? They are alternate interior angles, and know that alternate interior angles are congruent when two parallel lines are cut by a transversal. So we can form an equation to solve for the value of this variable here, which is n. So the equation will be 2n minus 45, or the measure of angle 2 is just equal to the measure of angle 1, which is n plus 3. So this is our equation. Now to solve for the value of our n, so this is the equation, we'll use the equation. So applying the subtraction property of equality to get rid of n here in this side of the equation, leaving a 3, we will subtract n to both sides. So to simplify, we have here 2n minus n, so with only n, we have minus 45, then n minus n here is 0, then copy 3. Simplify further. So we'll apply the addition property of equality, since we still have here the negative 45. So since it's negative, we will add its additive inverse, which is positive 45. So that negative 45 plus positive 45 will become 0. And we also add 45 here on the other side to make the equation still balanced. And simplify. So we have here the remaining n on this side. Since we have here 0, n minus 0 is n. And 3 plus 45, the answer is 48. So therefore the value of n is 48. Now, to know the measure of these two angles, we're going to substitute the value of n here, which is 48. So We have here 2n minus 45. We'll substitute 48 to n. So we have 2 times 48 minus 45. Simplify. We have 96 minus 45. So measure of angle 2 is 51 degrees. Then we will substitute the value of n to n plus 3. So we have 48 plus 3. The answer is 51. So measure of angle 1 here is 51 degrees. Are they equal? Yes, the two angles are equal. So in here we are asked to find the value of A and B given this figure, which one of the angles is known, which is 100 degrees, and here's A and B. So to find the value of A and B, we're going to determine its relationship or their relationship to the 100 degrees angle. So we'll start with A. What is the relationship of 100 degrees angle to A? They are what? What do you think? They are alternate interior angles with reference to this transversal. So you know that alternate interior angles are congruent. So the measure or the value of A is 100 degrees. Alternate interior angles are congruent. How about the value of B? So if we look at 100 degrees angle and the B, and we look at this transversal, they are on the same side of the transversal. So the value of B is 80 degrees since interior angles on the same side of the transversal are supplementary. So if this is 100, therefore B here is 80 degrees since 180 degrees minus 100 is 80 degrees. Now, if you notice, since there are 4 transversals and there are 2 sets of parallel lines, we have how many angles? We have 4 angles here. So 1, 2, 3, 4, and another 4 here. So 4 plus 4 is 8, and another 4 here. So 12 plus another 4, 16. There are 16 angles here. Is it possible that we can find the measure or determine the measure of all the angles here? Is it? Yes, by just remembering all the angle pairs that we have learned. So, shall we start? This angle here measures 100 degrees. Why? Since these two angles are vertical angles, and know that vertical angles are always congruent. This angle here is also 100 degrees. We're going to look at their relationship with this one. They are alternate interior angles with reference to this transversal. Or look at this angle here and this one. They are corresponding angles, and you know that corresponding angles are congruent. This part here, this angle here is also 100 degrees. If you notice, this angle and this angle are corresponding angles. Or if you look at these two angles, they are vertical angles too. So that's why they are congruent. This one, why is it? This measures 100 degrees. Since these two, we're going to look at this transversal here. These two angles are corresponding angles. So they are congruent. This one. So they are corresponding angles too. If you're going to remember B here, B is 80 degrees. And you know that B and this angle are linear pair. So 100 plus 80 degrees is 180 degrees. This angle here is also 100 degrees since they are alternate interior angles, or we're going to look at this angle here. They are vertical angles. Okay, so this angle here is 80 degrees. Why? Since this angle here is 100 degrees. So they are linear pair. Or we're going to look at the B. B has a value of 80 degrees. They are vertical angles. This angle here is 80 degrees. So they are linear pair with this 100 degrees. Or we're going to look at this. They are also linear pair. Or this angle here, 80 degrees, they correspond, or they're corresponding angles. This angle here corresponds to this angle here. If we're going to look at this transversal, then it's 80 degrees also since they are vertical. Or we're going to look at this part here, they are linear pair. This 80 degrees since if we're going to look at this angle here, they correspond. Or we're going to look at this angle here adjacent to this, they are linear pair. The sum is 180 degrees. They are, this angle here and here are vertical angles, or they are linear pair with this 100 degrees angle. And you know that if we're going to base from here, so this 80 degrees angle here is, and this angle here are, they are alternate interior angles with reference to this transversal. And they're also vertical angles, where they are linear pair with this 100 degrees angle. So notice that we only have two angle measures, 100 degrees and 80 degrees, when parallel lines are cut by a transversal. So that's it. Find the measure of angle 1, angle 2, angle 3, angle 4, and angle 5. Given this figure here, we have two parallel lines being cut by two transversals. But don't get confused about if you can see here more than one transversals, because we can look at each transversal individually. So in here, in this transversal, we can see one of the angles is known, the measure is known, which is 95 degrees, and we are going to find the measure of angle 2, angles 3, and angle 5. So let's answer first, or let's find first the measure of angle 2, since this is closer to this angle which measures 95 degrees. So what is their relationship? They are what? Vertical angles. Yes, correct. So they are vertical angles. So you know already that vertical angles are congruent. So the measure of angle 2 is also 95 degrees. How about measure of angle 3? I heard someone saying they are corresponding angles. Yes, you're right. These two angles are corresponding angles, and you know already that corresponding angles are congruent. So the measure of angle 3 is also 95 degrees. How about angle 5 here? They are on the same side of this transversal. So, and they are both exterior angles. So they are exterior angles on the same side of the transversal. And if you remember, exterior angles on the same side of the transversal are supplementary. So the sum is 180. So therefore, the measure of angle 5 is 85 degrees. How do we get it? By just subtracting 95 degrees from 180 degrees. The difference is 85 degrees, which is the measure of angle 5. Now, let's proceed to this transversal. We have this an angle which measures 45 degrees, and we are going to find the measure of angle 4 and 1. We start with angle 4 since it is closer to this angle here. And notice their relationship. They are both interior angles but not on the same side. So they are alternate interior angles. And you know already that alternate interior angles are congruent. So the measure of angle 4 is also 45 degrees. And how about angle 1? If we're going to observe, angle 4 and angle 1 are linear pair. So therefore, if angle 4 measures 45 degrees, the measure of angle 1 is 135 degrees. When you check 135 degrees plus 45 degrees, the answer is, or the sum is, 180 degrees. Give yourself a big clap and smile, for you are now ready to answer your SLK. Thank you and God bless.